Okay, ladies and gentlemen, we are on lesson 12, graphing the standard form. So we are going to match graphs to linear equations. So it says graphs A, B, and C represent three linear equations. Y equals 2x plus 4, y equals 3 minus x, and y equals 3x minus 2. Which graph corresponds to which equation? Explain. So we're going to start with the first equation, y equals 2x plus 4. And then in reviewing this, I know that the coefficient in front of x, 2, is my slope, and the 4 is my y-intercept. And then in looking at the next one, we have y equals 3 minus x. Again, the 3 is my y-intercept. And here, in looking at this minus x, that means I have negative 1 x. So that negative 1 is my slope. And then in my last equation, y equals 3x minus 2. Again, that's written in slope-intercept form. The y equals mx plus b, where m is my slope and b is my y-intercept. So 3 is my slope and negative 2 is my y-intercept. So now we need to match these. So as I look at these, I see the y-intercepts right here, and I can put them from biggest to smallest. So in scanning, the highest y-intercept is 4. So that would correspond to graph B. So graph B is y equals 2x plus 4. And then here, 3 is next. So in looking at the next one down, that's graph A. And then here, y equals 3x minus 2. That has to be graph C. Okay, ladies and gentlemen. So now where it says use graphing technology, where y equals x squared, and then experiment with each of the following functions. Record your observation. So we're going to start with a parent function, y equals x squared, to graph it. And then we're going to look at what would happen if I added different constant terms. So constant term is just the number on the end. So we're going to start here and graph y equals x squared plus 5. And then y equals x squared plus 10. And then lastly, y equals x squared minus 3. So I'm not going to graph all at once. I'm going to graph just a couple at a time and see if I can see some patterns. So I press y equals to get there. And then we have x squared. And then we also have y equals x squared plus 5. And then I'm going to graph. Now I notice that the parent function y equals x squared is there. And then if we look, the graph of y equals x squared plus 5 went up 1, 2, 3, 4, 5. Now, visually, it looks like the graph up here got skinnier. But if I zoom out, I can see that over time, they're going to fit in the same length. So if I'm looking at the graph of y equals x squared, and then compare it to the graph of y equals x squared plus 5, this graph went up 5. And then similarly, if we have y equals x squared plus 10, let's see how that does in comparison to the y equals x squared. And if I graph that, and let me just go to my zoom and then zoom in. And I'll just change my window here because I can see the graph is probably going to be up there. So I'm going to just change from negative 10 for my minimum to 20 and then graph. And then here I can tell from y equals x squared to y equals 10 that we shifted up 10. So again, this went up 10. So it seems like the number I add on the end is kind of like just going to be my y-intercept, similar to linear functions. But let's see and double check that with what happens if I subtract. So y equals x squared minus 3. So when I graph that, I can see that the graph shifted down 3. So it looks like if I did in general, the y equals ax squared plus bx plus c, that c is my y-intercept. And if we recall back to our transformations of linear functions, that also is a vertical translation because it's going up or down. So now we're going to look at what would happen if I multiplied this x squared term and made everything else 0 by different positive coefficients. So our parent function is going to be y equals x squared. And then we're going to have, well, what if I made it y equals 3x squared? And then what about y equals, we have like a whole number, let's do a decimal, y equals 7.5x squared. So I'm going to go back to my y function, clear out my other graphs, and then I'm going to put in y equals 3x squared, and then y equals 7.5x squared, and graph those. And if I notice here, it looks like the bigger the number, the skinnier the graph got. So in y equals a x squared, to just verbalize that pattern, the bigger a is, the skinnier the graph gets. And that definition right there, we would actually call that a vertical stretch. And then we're also going to look at, well, what happens if I multiply by negatives? So we're going to do y equals x squared, y equals negative x squared, and y equals negative 3x squared, and then we can see what's going to happen from there. So y equals, so I'm going to put negative x squared, y equals negative 3x squared, and then y equals negative 7.5x squared, and then graph. So I noticed something. This graph and that graph is actually a reflection, reflected over the x-axis. And then the bigger the a number got, or the coefficient in front of x squared, the skinnier it got again. So we got kind of two things going on here. Y equals negative ax squared. This negative piece right here does a reflection over the x-axis. And then this a does, again, a vertical stretch. So now we're going to look, well, we multiplied a, and we assume that a was bigger than 1. So we know if a is greater than 1, a is a vertical stretch. But now we're going to multiply a by fractions, and we're just going to look between 0 and 1. So let's say a is between 0 and 1. which that just means A is a fraction or decimal. And then what we're going to do is see, well, what effect does that have? So what we're going to look at is like y equals 1/2 x squared, or like a smaller fraction, y equals 1/4 x squared, or maybe even like y equals 0.4 x squared, and then lastly like y equals 0.1 x squared. So let me just rewrite this up here. So the last one is y equals 0.1 x squared. So let's put those in. So I'm going to press y equals again, clear out what I have. So y equals, we're going to have x squared, and then y we're going to see equals 1/2. So you can just type in 1 divided by 2 and then x squared. If you want a fancy fraction, I'll show you how to do that next for 1/4. You can press alpha and the x key, and it'll make a fraction for you. And then you can type in 1/4 and then x squared. And then y equals 0.4 x squared, or y equals 0.1 x squared. So let's look at those graphs. And we can see from 1 to 1/4, or to 1/2 to 1/4, that these graphs are getting wider. So the smaller the fraction, the wider it gets. So if A is a fraction, the graph gets wider. And then this is called, actually, instead of a vertical stretch, it's a vertical shrink. So now, ladies and gentlemen, we're going to look at completing the table for our inputs, -3, -2, -1, 0, 1, 2, and 3 for x. We're going to square those, do some work, and add 10, and then get an answer. So if I do -3 squared, we'll start by putting that in a calculator. You must put them in parentheses if you square a negative. And in doing that, -3 squared is 9. Same thing here. -2 times -2 is 4. -1 times -1 is 1. 0 times 0 is 0. 1 times 1 is 1. 4, and then 9. And looking at this parabola, I can see the vertex is 0, 0. Because we have symmetry around it. So this is my lowest point, and then here I notice the y values are 1 around it. Now if I do y equals x squared plus 10, and substituting that in a calculator, we have -3 squared plus 10, which is going to give me, oops, I wrote plus 9, is going to give me 9 plus 10, which is 19. Or we have -2 squared plus 10 would be 4 plus 10, which is 14. And then -1 squared plus 10 is going to give us 11. And then 0 squared is 0 plus 10, gives me 10. And then 1 squared, or 1 plus 10, is 11. 2 squared, which is 4 plus 10, gives me 14. 3 squared, 3 times 3 is 9, plus 10 is 19. So now what we're going to do is x squared minus 3. So we have our x squared numbers right here. X squared is 9, 4, 1, 0, 1, 4, and 9, because -3 squared is 9 and 4, and so on. So now I'm going to take each of those and just subtract 3. And then write my answer. So 9 minus 3 is 6. 4 minus 3 is 1. 1 minus 3 is -2. And then -3. 1 minus 3 again is -2. 4 minus 3 is 1. And then 9 minus 3 is 6. So now we observed the effects on the graph of adding or subtracting a constant term. Study the table and then explain. Well, what I'm going to do, this table is pretty big, so I'm going to look and relate like x to x squared plus 10. So if we have x, and I'm just going to write a couple values, but -3, and then here x squared plus 10. If I plug in x, the x value here of x squared, I'm sorry, I'm going to have to write another one, x squared plus 10, pardon my mistake. So the x squared value is 9, and then x squared plus 10 is 19. And then for -2, x squared is 4, and then x squared plus 10 is 14. Now, as I look, we're relating from here to here. We could see to go from 9 to 19 and 4 from 14, you add 10. So that's the same here when I go from x squared. If I go from y equals x squared to y equals x squared plus 10, what you do in the equation is you add 10. So we see that with the numbers as well. So what we're going to do now is complete the tables for y equals x squared, 1/2 x squared, and -2x squared, and then just see what happens with the numbers. So we already did the work for x squared, so I can just fill those in. 9, 4, 1, 0, 1, 4, and 9. And then if I want to do 2x squared, I'm going to go 2 times -3 squared. And then I'm going to write my answer over there so I can use the calculator. So 2 times -3 squared gives me 18. And then 2 times -2 squared. And then that gives me 8. And then that gives me, for 2 times -1, gives me 2. And then just plugging in our numbers. So 2 times 0 squared. Well, 0 squared is 0, so that's going to give me 0. 2 times 1 squared, order of operations says I do 1 times 1, which is 1, and then multiply by 2, so 2. And then 2 times 2 squared. 2 squared is 4, but I actually can do, and I see the symmetry in the table, so I'm going to see 8. And then 2 times 3 squared. Again, pairing up, I see that that one's 18, so this one's going to be 18. So now, in looking at how these are related, how do I relate 9 to 18 and 4 to 8? So in relating these values, you multiply by 2. And then in looking at this one, if I do 1/2 times the x squared, so 1/2 times -3 squared, and then again, to get that nice fraction, you hit alpha x. And I got 9/2, or 4.5. And then 1/2 times -2 squared. And if you don't want this in fraction form, also, if you just type in 1 divided by 2, it'll put it as a decimal for you. So that's 2. And then 1/2 times -1 squared. And I got 0.5. And then 1/2 times 0 squared is 0. And then 1/2 times 1 squared is 0.5 or 1. And then I see the symmetry, 2 and 4.5. And then in looking, how do I go from the x squared to the 1/2 x squared? So 9 to 4.5 and 4 to 2. So you multiply by half. And then in multiplying by -2, so again, we have all the work for the -2's, but these are just going to make them negative values. So this is just going to be negative of 2x squared, so -18, -8, -2, 0, -2, -8, and -18. To relate that from x squared to -2x squared, you multiply by -2. So to summarize our lesson now, we see this y-intercept of y equals x squared plus 5 and y equals x squared. Really, I could put plus 0 to see that the y-intercept is 0 or at the origin, and y equals x squared minus 4. These things are called vertical translations. So C is a y-intercept, but it also does a vertical translation. And then we have a couple things, a vertical stretch and shrink, or vertical stretch or dilation, and a vertical shrink or compression. So A right here is what does your stretch or dilation or shrink or compression. When A is bigger than 1, it makes the graph more narrow or does a stretch. If A is a fraction between 0 and 1, it does a shrink or compression. And then if A is negative, it does a reflection.